Well, let's talk about these Rust projects. You can install it on Linux, and I'm using Linux on ARM, but Linux on Intel works fine too. And all right, so I'm going to move this over here and try to resize it so it's not blocked. And I think that'll do. Yeah, looks like that'll do. All right, so I've installed the compiler and such that you need. It's just curl and Rust C. And then you can make a hello app. So let me go in here and cat hello world, hello app. There, that's hello world. Very much like it would look in C. It's pretty simple. The point of Rust is much more secure than C. It's going to end essentially all the vulnerabilities that we've been exploiting in this class, at least most of them. Not all of them, but most of them. That's the point. People are getting fed up with all these vulnerabilities that are pretty much caused by C, and Rust gets rid of them. So this just shows that the thing compiled correctly, so I can run it with there. So it runs and says hello. So my hello world program worked. And here I can make an integer app. So let me go in there. All right, and if I try to compile, I can cat it here. But here's my program. So I've got I and J. And one thing that's good about Rust is you can let it have a default type, and then I think you get a signed 32-bit integer, which is the same thing you get in C, the normal integer, but you can also put a colon and specify exactly what kind of integer it is, an unsigned or signed integer, and how big it is. So here, I make an unsigned 32-bit integer, and I set it equal to -5. When I try to compile that, it's going to stop and say you cannot have a minus sign there because I made it an unsigned integer. So it notices if you're doing a bad thing like that, and that's good. And here's a tutorial about all the Rust data types you can learn. And the same thing's going to happen here with this one where we're adding numbers. If I go in there, all right, I've got a thing called add.rs. And if I try to compile that, it's going to tell me my program, well, let me cat it. There. My program is I let a equals 1 and then a equals a plus 1, something you could do in any other language, but by default, if you don't specify otherwise, variables in Rust are immutable. So you cannot change this number if you don't add the mut keyword to indicate it's mutable, so it knows that. And that's why it's telling me here, consider cannot assign twice to immutable variable. Consider making it mutable, mute A. Now this might seem like an annoyance, but it is the opposite. You want your language to tell you when you make a little mistake so it doesn't turn into a big mistake. That's why this is very popular. It wins, for years it's been winning a contest where people ask, what is the language developers would most like to write in, and very many of them have said they much prefer to write in Rust. So let me go back here where I have overflow, demonstration overflow. So that's ov clear. That's cat ovc.c. Okay, so here's a C overflow. So what it does, I define, now notice how little sense this makes. I define a character variable, x, and then I set it equal to 230. This is already stupid. It's a letter, not a number. But in ASCII, a character variable is an unsigned integer. 8 bits that can go from 0 to 255 in C, and you get used to that, and you do stupid things like this that make no sense. 230 is not even a valid value. But anyway, now, then I'm going to just make a loop and add to that number, and when I run that, it's going to add up, and when it goes over 255, it's going to roll over like an odometer and get small again. And this is an integer overflow. This is very rude, and this doesn't happen in Rust. If you go into here, and cat the source code for Rust. All right, let's, it's, come on, what's going on here? LS, that's why. Okay, LS. Well, I'm having no luck typing. All right, there. So cat ov.rust, there we are. So this is the same thing. I made a mutable, unsigned 8-digit integer and I stored 230 in it, and then I add numbers to it. And when you run that, Rust will only go until it's about to overflow, and then it'll tell you, attempt to add with overflow. So instead of just running and giving you the wrong answer, it will stop and tell you, what are you doing trying to add to an unsigned 8-bit integer to go above 255? Something is wrong. I would rather know that than have the program just do the wrong thing. And then we get to the most important one that we've been exploiting in this class all the time, string overflows. So if I cat, all right, so here I define 2 strings, each 4 letters long. I print out their addresses, then I get a new value for one of the strings and print them out again. So when I run that, if I put in CCCC for new value for string 2, then it works. String 1 continues to be A, and string 2 contains C. But if I put in more, 1, 2, 3, 4, 5, 6, 7, 8 in C, then string 2 contains 8 C's, but string 1 contains nothing now. And if I add even more, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, then I added a lot to string 2, and string 1 changed. And this is the kind of thing that makes developers crazy. How were you supposed to see that coming? And that's why string buffer overflows keep on happening, even after we've known about them for more than 20 years. Developers keep making this mistake, and that doesn't happen with Rust. If you go into the directory where I'm working, and I did it again, I need ls, not cat. Okay, now I can cat. Here's the Rust version of that. Right, it looks very much the same, but you make mutable strings. You make them only 4 letters long here, and then you enter a new value for one of the strings and print it out. And if you run that and put in a whole bunch more data for string 1, then it just adds that to string 1, and it doesn't change string 2 at all. It automatically resizes the storage as needed to handle the longer string. It doesn't overflow or hit the end or anything. That's a modern language. So that's why it solves that problem automatically. The developer does not have to worry about this, and that's the big point. So there's more things to do here. I don't think I'll do them live, but you can go into the debugger and see how this works. The way it works in Rust is the pointer, what's stored at the location is not the string, it's a pointer to the string, and when the string gets longer, it changes the pointer to point to a different location that has enough room. So that's much better. And you can see that in here. And then command injection, we've had this one where you actually have something like ping minus C, and then you add data that came from the user, so you can add another command, and that is something Rust cannot fix. You have written code that constructs a command and then executes it on the system, and you've allowed the user to add unexpected data to that. This is a higher level error. This is not in the language. So if you do that in C, you get command injection, and if you do it in Rust, you also get command injection. It can't fix every problem, but it fixes a lot of them. And there's another one here too, where you can try some other ones like dangling pointers from heap use, where you have things that are left over from not freeing them. And you can have memory leaks, where you allocate memory, but you forget to turn it back. And both of those Rust does fix automatically, because in Rust, you don't allocate and then free as separate actions. What happens is you allocate, and it watches. Let's go down to the Rust example, and I'll show you there. Here's how you get something on the heap in Rust. You have a main routine that starts here with this curly brace. You define something with this box function. That's how you allocate space on the heap. And there is no free function. What happens is it watches. We were at this curly brace. It waits until you hit the closing brace, and as soon as you leave this scope, it automatically frees it. So it always gets freed exactly once. You don't have to think about it or do it manually. And you can't make the mistake of freeing it twice or not freeing it at all, which is what leads to those errors. So it's brilliant and so simple. And again, it's an irritation the developer does not have to be thinking about when they write code. It automatically takes care of something that would be dangerous in C. So that's why people love it, and that's why people are moving to it for Windows and Linux. The kernel of both Windows and Linux are going to contain a lot of Rust code in the future. It looks like the movements to do that are gaining a lot of steam. So that's all I wanted to show you there.